All right, this is the Yellowstone template file. I already made plotted the data point and added the trend line. Let me do it again for last 50 years worth of data. All right, so we have data until 2014. So let me start last 50 years worth of data. Select the data, and this is exactly the same what we have done before. So start at 1965. Insert charts. You can use any, but I like this one. Let me change the colors here a little bit. All you have to do is do colors. Let me make it more monochromatic. Oh, that's even worse. All right, that's good. And you can add the names of the thing. You can add that chart title, visitors, and whatnot. You can do anything you want, right? And we know how to add a trend line. The trend line is really the OLS the regression line, what we have done before. All you got to do is right click, add trend line. There are many kinds. I like the linear one. Add the linear one. Display the equation on the chart. That's good. Let me change the. This is good. All right, we're good. So let's move this a little bit here. This numbers look a little bad. You can go change this to number decimal 0, if you will. All right, we are all set. What this is saying is I can tell you the number of visitors, which is y, if you give me the year. Number of the year, that is your x, minus 53,525,080, whatever. Now, the idea is this x, to think of that year as an x variable really does not make much sense, right? It really does not make sense, and that it can be thought of it this way. Instead of thinking at 1965, 1966, and 1967, I can really think of this as year 1, this as year 2 in our data model, and we can extend all this all the way. And let's make this so we have 50 years of data, and I can do the exact same thing with, instead of using the year, calling it the period, and insert the same process again, the charts, and you see the obviously the graphs looks very similar. And you can do add the trend line here, add trend line, same linear, display the equation. Let me bring this equation down here again, make it number, and if the numbers are pretty big, we can get rid of decimals there, make it to 0. So this is the point I wanted to make. See the equation earlier, let me bring this all the way here, or I guess I can't bring it here. All right, these equations look very similar but different, and that is the real point here. Yes, the beta is same, 28.248x, but this intercept, 53 million here, 1,952,000, and so forth. So that is kind of the difference between regression in my mind and trend, in the sense when this time is really not an x variable, if you will. What this trend is really doing is it's just modeling the trend in the data, how the data is moving. It really doesn't matter we call this 1965 and this 1966, or we call this year 1 or year 2, we find the exact same model. Well, the numbers are different, but it's going to give you the same answer. If you're using this model, and if you want to predict say 2015, instead of x you put 2015 and you will get some value, and for 2015, that is your 51st data point, you put 51 in that x, and you'll get exactly same value. So basically why x variable is irrelevant. What this is really modeling is the trend in the data. So that is the real difference between regression and what we did here. And in operations this becomes important because most of our data is time dependent, if you will. Has a trend, has some shows some behavior, shows some pattern with time. So that's why we don't focus on regression too much, exact same mathematics, but we focus on the trend line.